Good day, everyone. In this video, we will discuss about anti-differentiation by substitution of exponential and logarithmic functions. In the previous video, we have discussed about the anti-differentiation by substitution involving algebraic functions. In here, we will now be discussing anti-differentiation by substitution involving exponential and logarithmic functions. And with that, we need to review some theorems on integrals yielding the exponential and logarithmic functions. For the first one, the indefinite integral of e raised to x with respect to x is equal to e raised to x plus c. For the second one, the indefinite integral of a raised to x with respect to x is equal to a raised to x divided by ln a plus c, where a should be greater than 0 and a should not be equal to 1. And finally, the indefinite integral of x raised to negative 1 with respect to x is equal to the indefinite integral of 1 over x with respect to x is equal to ln absolute value of x plus c. We will be using these theorems later on as we solve for the antiderivative of some functions. Let us take this example. Evaluate the indefinite integral of e raised to 3x with respect to x. Remember that we will be using anti-differentiation by substitution. Thus, let u be equal to 3x. When we get the derivative of u, which is du, the derivative of 3x is equal to 3 with respect to x. Therefore, if u is equal to 3x, then du is equal to 3 with respect to x. Looking at du equals 3 dx, when we divide both sides by 3, then we can get dx equals 1/3 du. Notice that we have dx here, so later on, using substitution, we will be substituting 1/3 du on dx here. Therefore, our given can be expressed as the indefinite integral of e raised to u times 1/3 du. Notice that 3x here was replaced by u, since u is equal to 3x. And dx is being replaced by 1/3 du, since dx is equal to 1/3 du. From here, we can now apply the theorems of anti-differentiation. Since we have the antiderivative of e raised to u times 1/3 du, then that is equal to 1/3 times the indefinite integral of e raised to u du. When we solve the indefinite integral of e raised to u with respect to u, then we will have 1/3 e raised to u plus c. But remember that u is equal to 3x. Therefore, our final answer will become 1/3 e raised to 3x plus the constant c. Example number 2. Evaluate the antiderivative of 2 raised to 4x dx. Let u be equal to 4x. Thus, getting the derivative of u, which is du, we will have 4 dx. However, notice here that we do not have 4 dx. Instead, we only have dx. So, we will divide both sides by 4, getting dx is equal to 1/4 du. Therefore, by substitution, our given will be expressed as the indefinite integral of 2 raised to u times 1/4 du. Notice, from the original given, 4x is being replaced by u since u is equal to 4x. And dx is being replaced by 1/4 du since dx is equal to 1/4 du. Now, we will be using this for the anti-differentiation. The indefinite integral of 2 raised to u times 1/4 du is equal to 1/4 times the indefinite integral of 2 raised to u du. Solving the indefinite integral of 2 raised to u du, we will have 2 raised to u divided by ln 2 times 1/4 plus c. multiplying 1/4 and this expression, then we will have 2 raised to u divided by 4ln 2 plus the constant c. Now, remember that u is equal to 4x. Therefore, we can express our final answer as 2 raised to 4x divided by 4ln 2 plus c. For our last example, evaluate the antiderivative of 1 over 2x minus 1 with respect to x. Let u be equal to 2x minus 1. Getting the derivative of u, which is du, the derivative of 2x minus 1 is 2 dx. From the given, notice that we do not have here 2 dx. Instead, we only have dx. Thus, to solve for dx, we will be dividing both sides by 2, getting dx is equal to 1/2 du. Therefore, by substitution, our given will be expressed as the indefinite integral of 1 over u times 1/2 du. Notice that we have replaced 2x minus 1 by u since u is equal to 2x minus 1 and dx as 1/2 du since dx is equal to 1/2 du. From here, we can now apply the theorems of anti-differentiation. The indefinite integral of 1 over u times 1/2 du is equal to 1/2 times the indefinite integral of 1 over u du. Remember that the indefinite integral of 1 over u du is equal to ln absolute value of u plus c. Thus, this one, when evaluated, will be equal to 1/2 ln absolute value of u plus c. Now, remember that u is equal to 2x minus 1. Therefore, substituting this on our answer, we will have the final answer to be 1/2 ln of the absolute value of 2x minus 1 plus c. I hope that you have understood the lesson. For our next video, we will discuss about antidifferentiation by substitution involving trigonometric functions. Thank you so much for listening and see you on our next video.